Picture this. You're standing on a beach right now, feeling the sand beneath your feet, watching waves crash against the shore. Now imagine all of that gone. No beach, no shore, no sand. Just water, water everywhere you look, stretching to the horizon and beyond. No mountains in the distance, no islands, nothing but endless ocean covering the entire planet. Sounds like science fiction, right? But this was Earth, our Earth. 3 billion years ago, this was reality. Dr. Sarah Chen discovered this truth on a research ship in the middle of the Pacific Ocean back in 2018. She was a marine geologist, someone who studies rocks from the ocean floor to understand Earth's past. Her team had drilled deep into the seabed and pulled up samples that were incredibly old. When she examined these rocks under a microscope, she found tiny crystals called zircons. These crystals are like nature's time capsules. They preserve information from billions of years ago. What these crystals told her was shocking. The chemical signatures inside them showed something that seemed impossible. About 3.2 billion years ago, Earth had no continents, no land masses, not even tiny islands. The entire planet was covered in water from pole to pole. At first, nobody believed her. Other scientists said she must have made a mistake. But then her team found more evidence. They looked at ancient rocks from Australia, from South Africa, from Canada. All of them told the same story. During that time period, there were no beaches, no rivers flowing into the ocean, no sediments washing down from mountains. Because there were no mountains. There was nothing to wash down. So what did this world actually look like? Let's go back in time and see. Imagine you could travel back 3.2 billion years. The moment you arrive, you'd realize you can't breathe. The air is nothing like what we have today. There's almost no oxygen. Instead, the atmosphere is thick with methane gas and carbon dioxide. The sky has an orange tint because the sun was younger and dimmer back then. Looking down at the ocean, you'd notice something strange. The water isn't blue, it's green. A weird, eerie green color. This is because the ocean is full of dissolved iron from volcanic activity on the seafloor. Imagine an entire planetary ocean the color of pea soup, stretching endlessly in every direction. The surface of this ocean is never calm. Remember, the moon was much closer to Earth back then. This created massive tidal forces. Waves hundreds of meters tall rolled across the planet continuously. But here's the strange part. These giant waves had nowhere to go. No coastline to crash against. They just traveled around and around the globe forever, passing through each other, creating patterns we can barely imagine. Lightning storms raged constantly across the surface. Without land to slow down weather systems, storms could grow enormous and last for months. Thunder echoed across the waves with nothing to absorb the sound. But the really interesting stuff was happening below the surface. Deep down on the ocean floor, in complete darkness, volcanic vents were erupting. These underwater volcanoes, called black smokers, spewed superheated water filled with chemicals from deep inside the Earth. The water coming out of these vents was hot enough to melt lead, reaching temperatures of 400 degrees Celsius. And around these vents, life existed. Not complex life. No fish, no plants, no animals. Just single-celled organisms so tiny, you'd need a powerful microscope to see them. These bacteria-like creatures didn't need sunlight or oxygen. They fed on the chemicals coming from the vents. They were extremophiles, life forms that thrive in conditions that would destroy anything else. These little organisms were Earth's only inhabitants, trillions upon trillions of them, clustered around volcanic vents, living in the only solid structures on the entire planet. In a sense, they were living on islands, but islands made of volcanic rock deep underwater in total darkness. Then something remarkable happened. Some of these organisms evolved a new trick. They figured out how to use sunlight to make food. This process is called photosynthesis. These new bacteria floated up toward the surface where light could reach them. They absorbed sunlight and carbon dioxide and produced sugar for energy, but they also produced something else as waste. Oxygen. At first, this oxygen didn't build up in the water or air. It immediately reacted with all that dissolved iron in the ocean. When oxygen meets iron, rust forms. So all this oxygen being produced by bacteria caused the iron to rust and fall to the ocean floor in what scientists call iron snow. Imagine underwater snowstorms, but instead of white snowflakes, red particles of rust slowly drifting down through the green water. This went on for millions of years. Layer upon layer of rusted iron settled on the ocean floor, creating thick deposits. Today we mine these ancient deposits for the iron we use to make steel. The car you drive, the buildings around you, the phone in your pocket. They all contain iron that came from this ancient process. Metal that formed when the first oxygen-producing life was poisoning itself with its own waste. Dr. Chen held pieces of this banded iron formation in her hands. Alternating stripes of red and black, each layer representing thousands of years of bacterial activity. She was holding proof that Earth was once completely different from anything we know today. At her conference presentation, someone asked the obvious question. If Earth was completely covered in water back then, where did all that water go? Why do we have continents now? What changed? Sarah smiled. She had spent years figuring out that answer. The transformation from a water world to a land and ocean world is one of the most dramatic stories in Earth's entire history, and it took over 1 billion years to happen. The change didn't happen overnight. Nothing in geology happens overnight, but about 2.5 billion years ago, things started to shift dramatically. Those oxygen-producing bacteria we talked about, they kept multiplying. They formed massive floating mats across the ocean surface like enormous green carpets covering thousands of square kilometers. They were pumping out more and more oxygen. Eventually, all the iron in the ocean had rusted out. There was nothing left for the oxygen to react with. So it started building up in the atmosphere instead. This kicked off what scientists call the Great Oxidation Event. Sounds boring, but it was one of the most important moments in Earth's history. The atmosphere started filling with oxygen for the first time ever. Now here's where it gets interesting. Remember all that methane in the air? Methane is a greenhouse gas. It traps heat and keeps the planet warm, but oxygen reacts with methane and breaks it down. As oxygen levels rose, methane levels dropped, and Earth's temperature crashed. Ice started forming at the North and South poles. Then it spread, and spread. Within a relatively short time, geologically speaking, the entire planet froze. Scientists call this snowball Earth. The ocean world became an ice world. The surface was covered in ice up to 1 kilometer thick. But underneath that ice, the ocean still existed. Heat from volcanic vents on the seafloor kept pockets of liquid water from freezing. Life survived in these dark refuges under the ice, waiting for the planet to warm up again. While all this was happening, something else was going on deep inside Earth. The planet's interior was gradually cooling down. In the early days, Earth was much hotter inside. The outer layers of rock were thin and constantly recycling back into the interior. But as things cooled, a different type of rock started forming. This rock was lighter than the basalt that makes up the ocean floor. Scientists call it granite. Because granite is less dense, it floats on top of the heavier rock below, like oil floating on water. As more and more granite formed, it started accumulating, building up, rising. The first protocontinents began to emerge. Small islands of granite pushing up through the waves. These weren't big at first, maybe the size of modern cities or small countries, but they were growing. Volcanic activity added more material. When these small continents collided with each other, mountains formed at the collision zones. For the first time in Earth's history, there were actual shores. Waves crashed on actual beaches. Rain fell on rocks and ran back into the sea. This created something new, tidal pools. Places where seawater got trapped and concentrated as it evaporated. These pools might have been crucial for the evolution of more complex life. One of the earliest continents has been named by geologists. It formed about 3 billion years ago and was roughly the size of Greenland. Eventually joined with other small continents to form larger land masses. Over hundreds of millions of years, continents grew, broke apart, and reformed in different configurations. But here's the question everyone wants answered. If Earth had twice as much water back then as it does now, where did all that water go? Dr. Chen's research revealed 3 main processes working together over billions of years. First, subduction. As tectonic plates developed and started moving around, ocean floor would sometimes get pushed down under continental plates. This is still happening today in places like Japan and the Pacific Northwest. When ocean crust gets pushed deep into Earth's interior, it carries seawater with it. That water gets trapped in minerals and rocks deep underground. Over billions of years, huge amounts of water got locked away inside the planet this way. Second, atmospheric escape. High up in the atmosphere, ultraviolet light from the sun hits water vapor and breaks it apart into hydrogen and oxygen. Hydrogen is super light, so light that Earth's gravity can't always hold on to it. Those hydrogen atoms drift up and up until they escape into space. Very slowly, molecule by molecule, Earth was losing water to the cosmos. This process is still happening today, just very gradually. Third, chemical weathering. When rain falls on rocks, water reacts with minerals and becomes part of them. The water doesn't disappear, but it's no longer liquid. It's locked up in clay, in other minerals, in the very structure of rocks themselves. As continents grew larger, more and more water got incorporated into rocks through weathering. All three of these processes working together over 1 billion years removed about half of Earth's water. The ocean got shallower, the continents got higher and larger. Earth transformed from a water world into the planet we recognize today. By about 2.8 billion years ago, Earth was no longer a complete ocean world. There was land. Not much, but it was there. And it was growing. The age of the last ocean world had ended. Dr. Sarah Chen stood on a volcanic beach in the Pacific, the black sand warm under her feet. She thought about the incredible journey Earth had taken, from a planet where standing on solid ground would have been impossible, to a world where most people never even see the ocean. She thought about the irony of it all. The oxygen that makes our lives possible is the same oxygen that helped destroy the ancient ocean world. The continents we live on only exist because of tiny bacteria that lived billions of years ago, because of volcanic eruptions, because of processes so slow we can't even perceive them happening. We carry that ancient ocean inside us. Our blood is salty like seawater. Our cells are basically tiny bags of ocean. We are, in the most literal sense, children of that water world living on borrowed land. The waves crashed against the shore and Sarah smiled. The story wasn't over. Earth keeps changing. In 1 billion years, the sun will be hotter. The oceans will evaporate. Earth might become a dry, dead world. But for now, we live in a special time. A time when water and land exist together, creating the conditions for complex life. The last ocean world gave birth to our world, and in its memory we carry the sea within us.